Okay, so we've done the word questions before. This isn't anything terribly new, just a matter of translating it into the equation, and then but this will be translated into two equations. We actually even had that before, so this shouldn't be terribly new. When they did it before, they tried to immediately make everything one variable. I set it up as two so that this wouldn't be something brand new to you. Okay, so with that in mind, let's go ahead and start with fruit company delivers in fruits in two boxes, two types of boxes. Okay. We have large and small. Those are going to be what we don't know. How much does each box weigh? We don't know. Okay? So we can call the large box, any ideas? L. And the small one? Awesome. We have two variables. L would be our weight of the large box. S would be our weight of the small box. Okay? We get 4 boxes that were large, 8 that were small, and have a total weight of 181, right? We don't know how much the large box weighs, but if we had 4 of them, how would I illustrate the weight? For instance, what if the large box weighed 10 kilograms? How much would 4 of them weigh? 40. You just multiplied 4 times the weight, right? If we don't know the weight, we still do the same thing. We just do 4 times the weight we don't know, 4L. Plus 8 boxes that all weigh what? We don't know. So we give it what? What letter do we use? We chose S. So 8S. And that total weight should equal what? 181. Delivery of 2 large boxes. So what does 2 large boxes look like? 2 times that weight. 3 small boxes plus 3. There you go. Should equal what weight? There's our setup. Does that make sense? They don't give us the equation directly. They give it to us and we have to figure it out. Now we have to solve this. There were 3 methods. I'll give you a hint. I'm not graphing these. Okay? I don't want, if I try to graph this, it's not even y equals mx plus b, but if I called one x and the other y, you could draw a relationship between this, but this would have a horrible y-intercept. So that's not one of our practical uses. We understand we're trying to find the point these have in common. Graphing helps us understand that. Okay? But we're not doing this by graphing. My second method that I encourage you to look for is substitution. Is this one that you would choose substitution with? I see some of you shaking your head. No, why not? What do I want if I'm using substitution? I either want a variable like an x equals, or what? Do I have any of those variables solved for? And if you tried to solve for any of those variables, you're going to end up dealing with decimals and fractions. Does that sound like fun? Okay, so we are going to our third method, elimination. And elimination, I'll have people that just go, okay, cool. No, that doesn't work that way, right? Or they'll look at this and, one second. Or they'll look at this and they'll go, okay, make it a big old addition problem, 6L, 11S, start write this down, 258, and like, so what did we do, right? The whole point of combining is to eliminate. Did anything eliminate? So that's not what we're doing. And that's why if you look at your notes on elimination, it says change the equation so one of the variables eliminates, right? I want them to be the same number and I want them to be opposite. Do I have any that are at least opposite? They're all positive, aren't they? Okay, so are there any that would be easy to make the same number? Why the L? There's a 2 and a, I could make those both a, in fact, I wouldn't have to change the top one, right? The top one's a 4. Could I change the bottom one to a 4? Now keep in mind though, I don't really want it to be a 4. I want it to be a what? Because I don't want it to, 4 plus 4 would be 8. I want it to cancel. So we use multiplication, and I take this bottom equation, and I'm going to multiply it all by what? Yeah, see, a 2 would change it to a 4, but a negative 2 is going to also change the sign. And that's going to multiply across everything. So what does 2L become? What does 3S become? And 77 times negative 2. I should hear some technology being checked. Thank you. Did I need to do anything to the top equation? So just bring it, line it up now. That was step 1. Step 2. My note said combine, cancel, solve. Right? When we combine the S's, what am I left with? Cancel. The 4L and the minus 4L. They're the same number and opposite. Those zero out. On the right side, what is 181 minus 154? I feel like something's off. Like these numbers are not going to be pretty. Oh well, I guess they're not going to be pretty. We'll deal with it. Okay? And last but not least, how are you going to solve for S? So we now know that every small box is equal to, and that would be 13.5 kilograms. That's all step 2. That's actually, and I told you guys before, that's about 80% of the work. It's so tempting just to stop there, though. Did we actually answer the entire question? Because they wanted to know how much was in each. And we got small. I still need, so what's our step 3? Substitution means I'm going to take this 13.5 and stick it in place of somewhere in one of the original equations. I'm going to plug it in for S. Which S? Does it matter? So you pick. Do you want the top one or the bottom one? I would argue the bottom one because the numbers are smaller. Does it matter? So if I did it to the bottom one, it would be 2L plus 3 times, what's S? 13.5 is equal to, see how that worked? You got a calculator? What's 3 times 13.5? Is that 40.5? Next step. So now we're looking at 2L is equal to, is that 36.5? Are we done? Last. So that L is equal to 18 point. Kiloliters. Kilograms. I don't know where I put KL. KG, I guess would have been right. Sorry about that. Is it right? This is what I love. You can actually check this pretty easily with your calculator, and I'm going to encourage you to do that. It's right. I should be able to take that 13.5 and plug it in for the S's, and take that 18.25 and plug it in for the L's, and it should make both of these equations true, right? So 4 times L, 4 times 18.25. Where did my calculator go? There we go. 4 times 18.25 plus, what's next? 4 times L plus, so 8 times 13.5 is what I heard. That would be 8 times 13.5 should equal what? I hope it's 181. Is that what it said? It worked, didn't it? It should work for the other one. 2L plus 3S should equal 77. 2L plus 3S would be 2 times 18.25 plus, was it 3 times 13.5 should equal, I love this. See, it's a sense of accomplishment. I do like systems of equations. I get that there's a lot of work to it, but to me it's like solving a puzzle. At the end, you're looking at it going, I did it. This is it. That makes sense? Okay? All right. Any questions on this before we continue? Okay. I think I had maybe 4 or 5 word questions in total. And then we have kind of an easy thing to end with, and I have an overview of kind of all the notes that I would encourage you to copy down and have maybe on a note card for the upcoming test, which is next week. Okay?
What day?
It'll be, because when we come back initially, we're going to have that assignment due, so it'll be after that. Okay?
So like Wednesday?
For you guys, it will be. All right, so Kayla will rent a car for the weekend. She can choose one of two plans. First plan has an initial fee and then a cost per miles. The second one has no initial fee but is 90 cents. We've done this before, haven't we? And I told you guys, hey, this is systems of equations. They're just not telling you that yet. Okay? So we have two different plans. We'll call plan 1 is equal to what? What's the initial fee? Plus, so 0.40 times, we don't know the miles, but miles, right? Plan 2, second plan has, so I don't need to put anything here, I just have the 90 cents per, okay? This is the systems of equations, but here's the key, they want to know when do the two plans cost when does plan 1 equal plan 2? Does that make sense? Basically, we have two equations, and we want to find where these lines will cross. The P's represent like the total cost of the plan. Okay? So when do these plans cost the same? What method are we going to use on this? You could graph it. It's an mx plus b with a y-intercept of 40 and go up by 40. That doesn't make sense, right? You could. Technology would do this beautifully. That's why if I was demonstrating this to a group and trying to sell them on one product, I would have a visual demonstration. That's a lot less intimidating. But that's not the best way to solve it, right? The best way to solve it in this one, is it set up, remember my second choice, is this set up for substitution? Heck yeah, we have a variable solved for, don't we? But what drives me crazy is I'll have people start moving things around to try to set it up for elimination, and I go, this is set up for substitution. I can take and set these two equal, so I can take this 40 plus 0.4m and I can put it in place. I can substitute it in because we're finding out where these two plans are equal. I can set the two plans equal. Does that make sense? So use substitution when it's practical. When it's not, don't. All right, so we have the first plan is equal to the second plan. I would encourage you just to leave the decimals. So we have technology that can handle that. How would you solve it? We're subtracting the 0.4. Make sure there's a what there, because we're subtracting the variable. 0.9 minus 0.4. 90 cents minus 40 cents would be 50 cents. Last but not least, so that m is equal to 8 what? Is it 8? Okay. This was all step 1, done. Step 2, substitute and solve, right? Are we done? Well, we answered one of the questions. For what amount of driving are the two plans the same? We solved for m. At how many miles? 80 miles. But notice the next thing they say is, well, then what is that's our step 3 on substitution. We're not done when we solve for one variable. We have to go back for the other one, right? Which means step 3 says, I'm going to take that 80 miles and do what with it? There's an S word for this. Substitute it. Into which equation? Does it matter? See, and that's where you got to be careful here, because plan 1 would be 40 cents plus 0.4 times 80. This one would be 0.9 times 80. And this one is, what, 40 plus 32? How about Oops, I don't know what I did there, but how about 72 bucks? What's 90 cents times 80? How about 72 bucks? So how much would each one cost when they're the same? Now, the only thing we're missing here would be normally I would have a step 4 where I write the answer as a point. It doesn't make a lot of practical sense. If we were to graph these, we would have one of them as X, the other one as Y. You could write the solution as a point, but that you take that solution and fill it in. Does that make sense? Okay. Any questions, concerns on this? Is this anything terribly new? That's why I told you we would have notes on these, but honestly, if you got through the 2 sections ago when we did equations and word questions, this isn't anything new. If you're struggling with it then, you came back. Welcome back. Okay? Struggle through it. Let's get past it. 2 down. Family has 2 cars. First car has a fuel efficiency of 20 miles per gallon. Second has a fuel efficiency of 40 miles per gallon. During one particular week, the 2 cars went a combined total of 2,000 miles for a total gas consumption of 60 gallons. How many gallons were consumed by each of the 2 cars? Oh, crud, right? Yep, I'll wait. All right, ready for this? This is basically kind of a version of dirt. And I know we've talked about this before, but basically it's like distance equals rate times. And the reason I say this is because I see miles per gallon, I see a rate 1, right? And then I see 40 miles per gallon, I see rate 2. So we have 2 rates, rate 1, rate 2. So far so good? But we're not really dealing with the distance. We're dealing with miles per gallon, not miles per hour. It's different, right? So it's not going to be times time, okay? We will have a distance. We will have a rate, but it's miles per gallon, so it'll be times gallons, dirt, so to speak. Okay? So the first car can go a distance of, what's the first rate? Yeah, 20 times, do we know how many gallons? We don't, do we? So I'm just going to put G. Okay? The second distance is going to be the rate, which is what? Times however many gallons that has. What does this 2,000 miles combined mean? The total what? Yeah, there's a D word I use for that. The total. If I totaled those distances, if I added those distances, it should equal 2,000, right? What's distance 1? So if I take 20G plus I might have a problem. I do. Give me a second. These are not the same gallons. There's our problem. Okay. Okay, give me a second. We don't know how many gallons were consumed for each car, correct? So we really have gallons 1 and gallons 2. So I'm going to have to mess with this a little bit. Sorry about that. No.
Oh, okay.
Basically, the gallons for the first car, I'm going to call that X. The gallons for the second car, I'll call Y. So this one will be 20 times X and 40 times Y. And the reason why I need to do that is because they didn't use the same amount of gallons. See that? So I can't just call them both G because they're 2 different gallons. Yeah, sorry about that. So that just changes this. Not a big deal. But now it's 20X plus 40Y is equal to 2,000. So sorry about that. The next thing it says is if we figured out how many gallons from 1 and how many gallons from 2, they would total 60, right? We don't know how many gallons the first one used, but we called it what? Called it what? X. Plus, we don't know how many the second one used, but we called it. And that should total, how many gallons did we use? Now we have a system of equations with 2 variables. Sorry about that, but that should be a little better now, okay? What method is this set up for? Currently, neither. If you argue substitution, you see a variable that's easy to get to. I could see that. Which variables would be really easy to get to? Either the bottom or the bottom. Either of those would be really easy to get by themselves, right? If you like substitution, you can do that. Solve for the x, solve for the y, substitute in the other equation. It will work. I would argue, because of the way these are lined up, it to me looks like we're really setting this up for elimination. Okay? But to eliminate, I need to pick one of the variables that we're going to eliminate. So which one are we going to eliminate? The x's or the y's? I heard y's. I'm fine with that. Okay? I probably would have chosen the x's just because they're smaller. And I could turn a 1 into a 20 or a 1 into a 40 just as easily. But you said y, so guess what? We'll do y because it doesn't matter. Okay? So if you want to get rid of the y's, which of those equations do I need to change? The top one or the bottom one? If I want those y's to cancel out, if this is a 40, this thing needs to become a what? So that means I'm going to multiply the bottom one times negative 40. So now I have negative 40x minus 40y is equal to negative 2400. Oh, buddy. I can now take that top equation, bring it down. 20x plus 40y is equal to 2,000. We're going to have to deal with a couple negatives because we chose to do the bigger number, the y's instead of the x's. It doesn't matter. You have a calculator, don't you? What is negative 40 plus 20? What is negative 2400 plus 2,000? See how that works? That wasn't that terrible. And our last step would be to divide by the what? So that x is equal to negative divided by negative makes that. Are we done? Remember, this is where we would have been done in our previous questions, but they actually want to know both. So once we solve one, we have to go plug it in to find the other. Which of these, I'll change color here just to make this clear, which of these original equations would be easiest to plug into and solve for? Somebody please tell me the bottom one. But that's just an x plus y. You want to mess with all of them. But guess what? Doesn't matter which one we use. Because this should be the answer for both of these, right? But it's easier to plug it into the bottom one. So let's take that x plus y equals 60. And we now know x is 20 plus what is 60? Y is equal to? Does that make sense? Is it right? Could you check it? I mean, look, up here. Does 20 plus 40 equal 60? Does it work up here? Does 20 times 20 plus 40 times 40 equal 2,000? It should work if it's right, right? What did we just say? 20 times 20 plus 40 times 40 should equal. It worked for both equations. Does that make sense? We've seen this before with two different types of tickets. Normally it was adult tickets and child tickets. Like I said, nothing terribly new here. We are going to be getting to inequalities, so you want to make sure that you have those. It's not a huge part of the test, but it is something that will show up on the next quiz. And we'll review it. We'll do a couple. Suppose there are two types of tickets to a show, advanced and same day. Okay? We want to know the cost of each one. We don't know the cost of each one. What could we call the cost of the advanced tickets? Somebody want to give that a letter for me? D for advanced tickets. Strange, but we'll take it. How much for same day? Okay, that makes sense. So I prefer BS, but we'll do DS. That's fine. So advanced tickets cost 35 and same day costs 20. We've used this before where we do cost times amount. Right? Cost times amount, total amount. We've done that before. What is the cost of an advanced ticket? Times, how many advanced tickets did we sell? We don't know, so we call it what? See, 70 is going to be our total tickets. We'll get that in a second. Plus, what's the cost of the same-day tickets? That is, why are same-day tickets less? That's a stupid question. Like, you're all desperate. Come buy the tickets early and we'll screw you, right? That makes no sense. That's all right. So times S, cost times amount. This should equal our total. What's our total? That's the total amount, that 1850. These are all equations we've used before. Review those old notes. I'll have a paper in a minute that'll review some of those with you, but you need to be able to set up these equations. What is the 70? See, this was a total, like, cost or total money. This is a total amount, right? What is the amount of advance tickets that we sold? No, that 70 is the total. How many advance tickets did we sell? We gave it what letter, though? Plus, how many same-day tickets did we sell? And if I added those two things, they should equal what? There's a total amount versus a total cost. This should be firing some memories for you, okay? What method is this set up for? If you love substitution, either that D or that S on the bottom is really easy to get to and you can do it. There's nothing wrong with it. I would argue elimination. Out of these two, what's kind of the smallest number that would be the easiest to get to? The D or the S? Which one do we want to eliminate? I like the S. Because even though, right, they're not the same, I can make them the same, but it's the smaller of the options, basically, right? So if I'm going to cancel these out, I need to change this S into a what? So we change it by multiplying. Once again, that's our old note. So I'm going to multiply this whole equation times what? And that's going to change that first D into a, that second S into a, and that 70 into about a negative 1400. Do I need to change the top equation? Did we need to change the top one? That's ready to eliminate, right? Just bring it. Question. Did we finish step one? Did we make the equation so something will cancel? That's the goal, right? Did we do it? What cancels? What am I left with? 15D. How about 450? Dividing that 15 away. How about D is? We had 30 advance tickets sold. Right? How many same day then? I'll give you a hint. They totaled 70, didn't they? So if I sold 30 at the first one, 30 plus what is 70? Right? Doing all right? It's on the quiz. Last word question. And we just have a couple inequalities and we're done. Two airplanes leave an airport at the same time, travel in opposite directions. One plane travels 91 kilometers per hour slower than the other if the two planes are 9,426 kilometers apart after 6 hours. What is the rate of each plane? Okay. This right here is a what? Total what? Distance. This right here is a what? And they're asking us to solve for a, what type of question do you think this is? Good, a good old dirt equation, right? It gets messier when they do this with jobs, like printing jobs and mowing lawns. It gets more complicated, but this is the beginning of it, that idea of dirt, distance, rate, and time. We do this, and it applies to any of those rates, any of those work questions, okay? So let's see. What is the rate of each plane? We're going to call the first plane, its rate what? Give me a letter for the rate, first rate's plane. Somebody say X. Okay, there you go. What are we going to call the second plane? You can do that if you'd like, but here's what I know. One plane is 91 kilometers per hour slower than the, so that means I know that if the first one is X, the second one is 91 slower than that, so what would that be?
X minus N.
Slower than the other, right? I wouldn't do X equals X, so yeah, Y minus. This one says that the first plane is 91 kilometers slower than the other. If the other one, this is the other one, right, is Y, then the first one is 91 slower than Y. Does that make sense? What that's going to do is that's going to immediately, we had questions kind of like this before, and they went straight to just going to one variable. But this right here, the minute I have an X equals or a Y equals, what method is that screaming? With a big old exclamation mark. It's yelling it, right? Substitution. Okay, ready for this? Do we know the first plane's distance? Not really, right? Do we know the first plane's rate? Not really, but we called it what? Times. Do we know the time? There we go. Do we know the second one's distance? They didn't give us the total distance. We'll deal with that in a second, right? Do we know the second one's rate? So we called it what? Times, what's the time? Okay? What is that 926? And I love the way that you put that, because if they're going opposite directions, then their distance apart is growing. So it is a total distance. If I added up the distance that the first plane went plus the distance that the second plane went, it should make 9426. Substitute, replace D1 with what? I'm tired of writing that as x times 6. What is x times 6? Plus equals. We now have two equations with two variables. What method is it screaming for? Replace this x with what? Do you see that x? Substitute. So in place of that x, we put y minus 91. 6 times what? Plus 6y is equal to 9426. Can you solve this? Take the 6 and what with a d? 6y minus about 546 plus 6y is equal to 9426. Can you solve this? Combining like terms, what is 6y plus 6y? Minus 546 is equal to 9426. We now have a two-step equation. I'm going to scoot this stuff down. Sorry about that. A little more space. Okay. Two-step equation. How would you solve this? I wouldn't subtract if it's minus, right? To undo the minus, we 12y is equal to 9972. Is that divisible by 12? I sure hope so. What is it? We now know y, which is the second plane's rate, right? Do we know the first plane's rate? Do we know x? Could we figure it out? Because x is equal to what? So x is equal to, what is 831 minus 91? Seven something. Is it right? If two planes are going in opposite directions and these are their rates, did they end up going 9,426 miles apart? Well, take the first rate, 831 times 6. That's how far the first plane went. Take the second rate, 740 times 6. That's how far the plane went. If they're going opposite directions, what's the total distance they were apart? Did I mess that up? You guys are looking at me like I'm crazy. No, I'm feeling good about this. So how would I get the total distance? What would I do with those distances? Plus, is that the total distance? See how that works? That, I think, is the trickiest one you're going to see. Probably not, maybe a little bit on the test, but probably not to that level. Keep an eye on your homework. I don't have an extra worksheet for this. My primary goal from this section is that you can solve systems by graphing, substitution, and elimination. That's what I'm emphasizing. The word questions aren't anything new. The inequalities, kind of new, but we've done this before. You had this in homework before where you graphed a linear inequality. It's not a huge deal, but we're going to build on this. So let's start with what we know. Do you know how to graph x equals what? It's been a while, but we've graphed that before, right? You would start on which axis? Starting on the x-axis, we would go to to 1, and we would draw a what line? Now, what you have to remember with inequalities, before it was like open dot, close dot, parenthesis, or, but when I'm dealing with a line, is this line going to be solid or dashed? And equal to makes it a solid line. So you graph x equals 1. What does it mean less than or equal to? It means that basically our solution is anything on this line and anything less than this line. So that would be what direction? Anything to the left of this line would also be part of the solution. Anything on this line and anything to the left of this line would be part of that solution. Okay? What if it's y is greater than 4? You start by asking yourself, can you graph y equals 4? Can you graph that? Where would you start? On the y-axis at? And we would draw a line that's what? Horizontal, but keep in mind this one wouldn't be right this time, right? Because the last one was equal to gives us a solid line. This one is not equal to gives us a dashed line. That's how we note whether it's equal to or not equal to. Now we have y is greater than 4. Where are values greater than this? Notice it doesn't make sense to say left or right anymore, does it? When it's x values are left or, when it's y values are above or, and greater than would be what? We would shade everything above this line, is what we would shade. Any questions, concerns on that before we continue? That should be a review of something we've seen in prior sections. We're now going to do it with systems. Okay? And I've got just, 3 that we're going to go through. Okay? But before we do, anyone need that before it goes away? Going. All right. I don't know, raw eraser. There we go. These would be the types of questions that you can expect. Dirt. We had one where we had 2 distances and we add them, but we started with dirt. We had the amount of x, the amount of y. I don't know why I have a z there, so I need to modify this. This is actually something I do. Sorry about that. In my Math 51, this comes up again, kind of in a bigger fury, but it's not anything new. There we go. And so I just need to clean that up real quick. That's basically it. Okay. So what I'll do is I'll send this to you guys over Remind. Okay. But what I want to emphasize is the 3 methods that you need to know for systems of equations: graphing, elimination, and substitution. If there's either of those that you're struggling with, those are the methods, right? And if you've gone through the notes that I asked you to go through, you showed me that you did those notes, you've got those 3 methods down. Okay? From that, there were also word questions. We have the dirt, we have the amounts, we have the cost. That's not anything new, but I put a couple examples up there. Okay, so our word questions, mostly we had dirt, amounts, and costs. And then we end up with a system equation, we solve it. This, Alex focuses a lot more on that initial cost plus a rate over time. Those, you might expect one of those to pop up too. Okay, but what's really the only new thing past that is this. Graphing inequalities, which we've done before. If y is greater than, what type of line will we do? Dashed. There's a dashed line. And greater than means we would shade up. Does that make sense? If y is greater than or equal to. Now that equal to makes it a solid line. But greater than means I still shade what? You see how that works? If y is less than means, and we shade it. What if it's less than or equal to? What does the equal to do? Makes the line solid, but we still shade it. I don't know that my picture makes it any better, but I thought colors are pretty, so there you go. Okay? I'll leave that there for about another minute, but that's just kind of an overview of everything from this piece of pie. Okay? This last part's going to go pretty quick. There you go. Take a picture. It'll last longer. What? Yeah. I'll even pose. That's awesome. You're like, I'm on Twitter right now saying the opposite, but that's okay. Oh, I'd be like that. Jeez. All right. Start with the first one. Do you know how to graph y equals 2x plus 7? Gosh, I sure hope so. We spent a lot of time on that, right? What point do I start at? 7 is not a point. It's good, though. You know we start at 7. That 7's on the what axis? Good. But that's still not 7. It's called, that's the y-intercept, right? Because if you put this on the x-intercept, they will happily mark you off. From there, what's the slope? Up 2 over, if I want another point, up 2 over, if I want to go backwards, down 2, back 1. Is that the correct type of line? Greater than or equal to, that equal to makes the line. What does greater than mean? Shading it what direction? But be careful, because if you do all of this, you're going to get yourself lost. So I recommend saving that. If anything, you could maybe put a little up arrow from there to know that we're going to go up from there, just to keep track of it on the paper. How do you do y is less than negative 2x minus 5? What's the point we start at? I like that. 1, 2, 3, 4, 5. And what's the slope? Right 1. If I want another one, down 2. Right 1. If I want to go backwards, up 2. Left 1. Is this line correct? Why not? No equal, right? This should be, hopefully you have a good eraser. That makes sense? What does less than mean? And I love people who are saying right or left, because it's so tempting with when we've done x's and done right or left, but we're saying y is less than. That is not right or left, that is up or, and so less than means we're going to go below this. So I'm only going to shade the overlap, which means it has to be above the solid line and below the dashed line. Do you see where that overlap is? There's 4 regions. Is it over here? Not happen. Is it on the top? Is it above the solid line? Yeah. Is it below the dashed line? Don't shade it then. Is it right here? Is that above the solid line? Below the dashed? That is where we will shade. Is it in this bottom region? Now it's not above the solid line, is it? If you don't like this, you can lightly do this. I will also do this with color. It kind of makes it kind of fun. I can go everywhere above this and everywhere below the dashed, right? But where's my only answer supposed to be? Where's the answer really supposed to be? The overlap is it. That's the answer. Okay? Any solution is any point in the overlap or on the solid line. Solid, there's no E at the end of that, I don't know. Next to the overlap. So basically anywhere it's green and anywhere where that solid line touches the green, those are all of our solutions. Does that make sense? Okay. Can we do another one? Any point in the overlap or on the solid line next to the overlap. Going down. First one. Can you graph y equals negative 5x plus 4? Where would you start? I heard 0, positive 4. Plot a point. From there, what's the slope? Down 5 over, if you want another point, go down another 5. 1, 2, 3, 4, 5, over another 1. What type of line am I supposed to draw? Double check before you have to go back with a big eraser, right? This was a solid line. We drew a solid line. How do I do y is greater than 2x plus 3? What point? What's the slope? Up 2 over. What type of line? Save yourself some effort and make it dashed before you start. The only other thing you have to do is make sure you shade this correctly. Where is it supposed to be shaded compared to the first one? I'll do that as yellow. Less than is below the solid line, right? Everywhere below the solid line. Now you might want to save on the shading and just wait for a second because that's not all our answer, is it? What does y is greater than mean here? Everywhere above the dashed line. Where is the only area that we can really keep? What do we keep? Just the, I got the wrong eraser. Just that overlap. That's really our answer. It's just in the overlap. Okay? Any questions, concerns on that? I have one more, and this to me is not an A-basket issue, but I wanted to make sure you weren't surprised by it. If I ask you to graph these, for the first one, what is the y-intercept? Ruh-roh, what do we have to do first? I heard solve for getting y equals mx plus b. It's really an inequality, but we're getting it in slope-intercept form, right? So how would you get that y by itself? Make sure you add to deal with subtracting. What's left on the left side is less than or equal to. Okay? Do we have y by itself yet? So last step is 2. So that y is less than or equal to Do the same thing with the other equation. 5x plus 2y is less than -4. How would you solve for that y? I heard subtract the 5x. 2y is less than. Why didn't we flip the inequality when we subtracted? Only if you multiply or divide by a negative. Be careful with that, okay? Our last step is to what? Am I dividing by a negative? Then am I flipping it? Then don't flip it, right? It added a little work, but that's something that should not be an issue at this point. Fair enough? Can you now graph it? Oops, too far. Got all excited. The first one has a y-intercept at what? With a slope of? Solid or dashed? Second one has a y-intercept of what? And a slope of? Solid or dashed? Where will I shade? Compared to the solid, I want to go below the solid. Compared to the dashed, I want to go below the dashed. Which of these four regions is below both of those lines? Yeah, it is. This region? Is it below both of them? This region? It's shaded in. It says to find a one point in the solution set. I would just argue, where are our solutions? Anywhere we shaded, and or on the solid line next to the shading. So for instance, here's -2, 0. Is -2, 0 in the right region? Not quite, is it? Here's -2, 1. Is that in the region? Is it in the shaded region? No, but it's on the solid line next to the. So one solution would be that -2, -1. What about -2? Let me change the colors. What about -2, -2? -1, -2. My 2's are sucky right now. But the idea is what? Anything in the shaded region, any points in there would be a, or anything on this solid line next to the shading. Does that make sense? So -2, -1. -2, -2. -2, -3. Anywhere below that point. Okay? Any questions, concerns on that? You could have done like 0, -5, anywhere shaded down here would be a solution. Okay? That's it, guys. That's why we are going through this one pretty quick. Prepare for this next quiz. The quiz is next week.